So as India charts its course towards net zero and energy independence, alternative fuels are emerging as critical enablers for a more sustainable and secure transportation future. The government's push towards gas-based economy, the E20 ethanol blending targets and green hydrogen mission are signaling a decisive shift. However, scaling these alternatives, be it CNG, CBG, LNG, ethanol, biodiesel, and hydrogen across diverse vehicle segments requires more than just the ambition. It demands technological readiness, robust infrastructure, cohesive policy, and a skilled workforce aligned with the needs of the new energy system. So I'll kick off the session by understanding each individual alternate fuels that we have in the market. I'll begin with Mr. Chaudhary. Talking of CNG, CNG is one of the alternatives that has got a very good distribution. It has got very strong acceptance in passenger vehicles, in three-wheelers, and even in two-wheelers. We've seen Bajaj Auto introducing that alternative. How do you see that segment in the three-wheeler space and small commercial vehicle space, and what share of the market do we see CNGs accounting for, given the fact that we have many EVs also coming in there?
Okay, good afternoon. Thank you, Ketan. Since morning, we are talking about the various types of fuels and technology adaptation for car, commercial vehicles. Particularly in three-wheeler, we have been lucky. So these technologies are already matured in car or passenger vehicles. So for us, the challenge was to adopt the technology, applicate it particularly from single cylinder point of view, because in three-wheeler, we have single cylinder. So that was the major technological challenge. Pre-COVID or in BS4 era, this three-wheeler market was mostly dominated by diesel. So 70–80% was diesel and 20% was CNG. Of course, CNG infrastructure was also not available across all over India, and EV was just emerging. Post BS6, because of technology adaptation, the cost of diesel vehicle has gone up. The complexity in the entire powertrain has increased. So that gave us scope to CNG, particularly, to increase their market share. So earlier in 2016 to 2019, this three-wheeler segment was having around 70–80% diesel segment and around 20–30% CNG. Now post-COVID or post-BS6 era, now that market share has, it is a clear trend that diesel is degrowing. Now diesel market share has come down to 18%, and every year it is degrowing by 2%, 4%. Whereas CNG is around 40–45%. EV is emerging there in that three-wheeler segment. So EV and CNG are going head on. It means EV is also 40–45%. In EV, mostly L3 segment is growing, whereas L5 is still in the mature stage. So in CNG, we have, basically it's mostly driven by a cost of economics, basically cost of operation. So, but when we worked out the strategy for product, technologically there are no major challenges. We have developed all our product portfolio based on the regulatory requirements and based on the consumer requirements.
So this segment probably is the only one that has transitioned well towards a cleaner alternative, given the fact that the cost economics have been addressed and it's also cleaner on the environment.
Yeah, correct. So diesel, earlier it was in, but diesel is still preferred in cargo segment because of its low-end torque, better low-end torque, gradability. Whereas when it comes to passenger segment, so it's purely dependent on cost of economics. Basically, if you see cost of operation for CNG vehicle, it's less than 2 rupees per kilometer, whereas in EV it's in less than 1 rupees per kilometer, whereas in diesel it's more around 3.5 rupees per kilometer. Right. And if you overall see the cost of acquisition, so EV is somewhere around 40 rupees per kilometer at the beginning. Diesel is around 32 rupees and CNG is around 28 rupees per kilometer.
So definitely, unlike the other alternative fuels in the market, CNG definitely has a good lead, and it is likely to have a much better penetration going ahead in the future.
Yeah, in three-wheeler passenger segment, CNG is the preferred solution. EV is, of course, EV is also equal to CNG, except that total initial cost of acquisition. And in cargo segment, still diesel is preferred.
Right.
And also, the most important is infrastructure available. CNG infrastructure is also
expanding at a rapid pace.
More than 7,000 outlets are available across India. So wherever CNG infrastructure is available, The
So
CNG
amongst
is
all the other alternatives, CNG, at least in the three-wheeler space, is in a good position right now. Mr. Deshpande, if I could get you in, Cummins has been a diesel engine specialist for years, but it has made rapid strides in recent times, and you've showcased your helm technology at Bharat Mobility Show in various editions as well. What's Cummins's personal view on about the hydrogen economy, and I mean, what are the prospects? What are the challenges? Can it really make it into Indian market and become mainstream, just like how we've seen CNG becoming a relevant alternative in the three-wheeler space? I mean, it's a completely different gas infrastructure, various challenges. Help us understand a little bit about hydrogen as an alternative.
Yeah, thanks, Ketan, and thanks to Autocar Profession. It's a very good event. I think I'm learning a lot through the session myself as well.
Thank you.
To your specific question about what Cummins' view in terms of these alternate fuels is. So you're right, we have actually come up with a strategy because we quickly realized that having a pure diesel powertrain was going to make us stand out in a bad way with respect to how others are operating in this space. So HELM, which is high efficiency, low emissions, and multi-fuel product, that's our product strategy going forward. So all of our major platforms actually as of now are undergoing this transition with respect to making them multi-fuel capable and across various regions and applications, basically. So that's the strategy. Coming specifically to your question about hydrogen, from a Cummins perspective, hydrogen internal combustion engines are probably that bridge technology, what we spoke about, which will become the choice until we move towards a full electric kind of a fully sustainable solution. Very specifically in that space, I think what's beneficial in a hydrogen ICE kind of an environment is that you can actually carry forward most of the aggregates that you have today on the vehicle. For example, at the Bharat Mobility, Tata Motors along with us actually showcased one of their products, which is a 55-ton tractor trailer. So this is today's your 55-ton tractor trailer, which is used in large cargo segments, and it is using exactly the same aggregates as would be in a diesel environment. So you are actually carrying forward a lot of learning and a lot of economies of scale. What is changing is the powertrain, and that is the hydrogen ICE, right? So it's still an internal combustion engine. So again, from an OEM perspective, like us as Cummins, we are carrying forward a lot of learnings, a lot of parts, a lot of scale, and Helm comes here again into picture because using this approach where you can use the same carcass for a multitude of fuels, you can actually again leverage the scale and ensure that the cost of technology actually comes down for each of the fuel. So that's the whole logic.
You brought in the modularity with that Helm platform, but it's still at a significantly higher cost, and at the end of the day, the infrastructure matters. Without the distribution, it's a challenge. So when you look at the market, when you prepare the technology, what's the sense you're getting? What will it take for India to popularize hydrogen, especially to a price-sensitive market like commercial vehicle?
Yeah, again, that's a great question, and I am actually happy that India is actually at the forefront of all of this. So just from a Cummins perspective, since we wear a global hat, I can tell you that India is the only region where hydrogen ICE is getting deployed globally. It's the first installation, and this is actually the first time that in this space we are able to reverse the trend. So globally is looking at us to say that, okay, you help us learn how hydrogen ICE operates in a commercial vehicle environment. So that's the first.
So used cases in India are being shared globally.
Yes, being much ahead of the curve than the rest of the market. Now, to your point, yes, it's definitely the aspect of cost efficiencies and the TCO, what we spoke about earlier in the panels as well, is very important for India. And it's definitely one of the lowest TCO, most TCO sensitive market, I would say, globally. In that sense, what's important is, number one, cost of technology in terms of the aggregates that we are trying to add. So the cost of engine itself, the bigger cost in a hydrogen environment actually turns out to be the fuel delivery system, which is basically the carbon fiber tanks, which store hydrogen at a high pressure.
Which is a very capital intensive investment, isn't it?
That's absolutely a capital intensive proposition. And that's one of the places where, again, though, what I'm happy to see is that through National Hydrogen Mission, India has actually started investing through MNRE in what they are calling as a pilot program, wherein they have actually asked OEMs to demonstrate running a small fleet where government is actually coming in and subsidizing the cost of running a hydrogen vehicle versus a typical diesel or a gas vehicle. They're actually subsidizing that cost and encouraging the industry to actually demonstrate how hydrogen economy work will work for a country like India. Right. And through a very active engagement with industry, what the government is trying to do is also trying to find out what are the infrastructural points where they should actually have the hydrogen infrastructure from a fueling station perspective, from generation perspective available. So that's a very good approach, I would say. Of course, to be honest, while I'm sounding so optimistic, we are still years away from when we will actually see a hydrogen truck running on the road. But I can assure you this, if there is a country that will go that route, I think we are further ahead in that curve right now.
That's heartening to hear. Mr. Donakonda, I mean, if I could just get your views, Daimler Truck Innovation Center works on global solution for Daimler Trucks, the largest truck maker in US, largest in Europe. How are you seeing the transition of alternate fuels in some of these evolved markets, and what are the learnings that you've got where India could actually implement and make it a lot more accessible technology from a commercial vehicle standpoint?
Yeah. So as far as the commercial vehicle segment in the US or the Europe, or when I would say to the extent to cover even the triad markets, which includes mostly Japan, the US and Europe, the focus is to go to total carbon neutrality by around 2039-ish time frame. Right. And it's also a decision taken within my company that beyond 2039 we'll not sell a single carbon emitting vehicle in these markets. But then there are also geopolitical factors. If you want to sell vehicles, you also need people to buy those vehicles.
Absolutely.
So today, if I want to sell a truck, or I want a person to buy a truck, they look at three important factors. One is, what is the convenience of buying a particular truck with a particular technology? People have been used to diesel so long. Diesel engines can run for 1 million miles plus, and diesel trucks are trouble-free for the entire duration, except the periodic maintenance that you need to do. And the second thing is you need to have a price parity. Right. Like let us say if I'm buying a diesel truck versus buying an electric truck. Today, if I look at it in the US market, as far as commercial vehicles are concerned, considering the fact that battery is almost 50% of the cost of the truck because you're using batteries of close to 500, 600 kilowatt hour, and they still don't have the kind of a range that you look and the inconvenience with the amount of time that goes in, unless you have a megawatt charging infrastructure, which requires to have the quick charging you're looking at. So these are some of the things which can be pain areas because of which customers may not want to switch. And finally, you need an infrastructure. So it's three things. One is you need to have the product which gives you the assurance that, yes, this is the technology I want to move to. Second thing is, do we have a price parity because the upfront cost? And finally, do we have an infrastructure? So when in the direction towards ZEV, most companies have taken ESG targets to have so much of their fleet which are going to be zero-emission vehicles. Right. The second thing is we are also expecting a lot of things in the policy globally. For example, in the US, you are having two legislations, especially in California, for you had this for fleets. You had one regulation, we called it ACF, and then you have ACT, one other one was for the clean trucks, and advanced clean trucks, advanced clean fleets. But now you want to have the regulation for trucks, and you tell the fleets get a waiver telling them, no, it's not really practical for us to move to this. And then now you need to sell these trucks when the fleets are not willing to buy these trucks. Right. There are no takers. These are some of the challenges we had. So what helps in our transition to zero-emission vehicles? In India, the factors could be very different. For example, here it's about your balance of payments, your forex costs, how much is your dependency on what you can make locally. Are different. But there it's mostly clearly driven by regulations or a decision taken.
What will it need from India's standpoint, in your assessment? What will it need from India's standpoint to make hydrogen a mainstream alternative?
I think from an India standpoint, it's mostly, again, a pure TCO game, because the TCO is a factor of all the 3 points that I said earlier, because it's also about upfront cost of the vehicle, your running cost of the vehicle. So if I look at how we expected the price point in Europe for hydrogen to vary, we don't see it coming down below 5 euros per kilogram anytime soon. And at that price point, I think you already lost out on one important parameter in terms of cost. And then the question is, you need to have hydrogen produced at scale, a really large scale, for the prices to significantly come down. And if that has to happen, it has to also be a priority of the governments or key players in the market, maybe the energy companies and all of them decide that they want to put a massive thrust, then it always becomes a chicken and egg story that I have the fuel, do I have the trucks? When I have the trucks, do I have the fuel?
Chicken and egg, yeah.
That dependency will always come in. And then nobody wants to keep making heavy investments
Yeah, first
now.
we need the fuel, then we need the right cost.
Yeah, so make heavy investments now and see what comes later. So when we're faced with this, we decided to go with an approach towards the powertrains mostly focused on 4 dimensions. One is we continue with diesel and make the slow transition, because diesel in most OEMs today is still the bread and butter of what keeps the company running, because it is the money and the profits that you make from diesel trucks which help you in investing in the other technologies.
Right.
Second thing is the easiest means to get into the zero emission target wherever you want to have them is battery electric vehicle at this point of time. But then
from a CV standpoint, it is always seen as inefficient.
Then you still have the issue of range, the charging time, and all of that. So then we thought the next option was hydrogen and fuel cells, because in hydrogen and fuel cell trucks, we're able to achieve upwards of 1,000 to 1,200 kilometers per fueling. When you
one cycle
fuel up completely. Then the facts still remain, the cost is still very high, and you're completely switching off from one technology to another. The last option was, and of course the most promising option still remains hydrogenized. The fact still remains, with hydrogenized, you're having a diesel-like efficiency, because it's still going to be around 40 to 45% thermal efficiency. Diesels, we achieve up to 45% thermal efficiency.
Right.
And so hydrogens, we're working towards it, but at this point of time, there's no promising solution with reference to direct fuel injection in hydrogen. Right. Most of the concepts that we have, studies we have, are on port fuel injection, which is which cannot give you the kind of torque, the low-end torque that diesel gives you. But then the advantage of hydrogen engines being the mainstay in the future is that all OEMs have made a lot of investments in engines.
Right.
With just around 20% change in these engines, you are able to comfortably make the transition to hydrogen.
Right.
So, and I would say for Indian market, since you asked me how it matters, I think India is able to produce engines at the lowest prices anywhere in the world.
Right.
And I think we have built the capabilities, the entire value
and
chain, supply chain.
Players like Bosch are an absolutely critical cog in the wheel.
And we're really not behind anyone else in the world in terms of engine technology, because I think at this point of time, even from Euro 6, we reduced the gap from the traditional 8-year delay for a regulation to come in to around 5 years, and I think now we're almost there. Right? So
let me bring Mr. Anthony in. What do you think? I mean, Bosch has solutions on multiple powertrain. Another element of alternate fuel, which I'd like you to reflect on, is the CBG, CNG from a pass car perspective, and ethanol as well. First, your thoughts on hydrogen. You have solution. You showcased it recently. How do you see hydrogen evolving, and what do you think of CBG, CNG, and E20? E20 is achievable by October. The India is going to have significant distribution of that. How do you see these 3 alternatives, and what role they're going to play?
Yeah. First on the hydrogen, I think I second a lot of things what they said, especially when you want to look at net zero and in commercial segment. Yes, there are people who are working on electric. Even Europe, for example, went all electric in truck, but now we are hearing them come back to ICE with hydrogen. And Europe has accepted in CV segment that hydrogen ICE is carbon neutral. So hydrogen ICE gives about less than 1% of carbon dioxide compared to diesel. So it's already accepted as a carbon neutral powertrain. So when we want to look at net zero, that's a clear winner. Hydrogen ICE can support us there. Yeah, and as already said, fuel price is one aspect. That's a bigger topic to be handled. But that's an opportunity for India from moving towards from net importer to net exporter of energy.
Right.
And if you look at the crude import, if I look at IEA report, even from 2022, almost 25% of energy supply import was oil, and more than 80% of that is used in transport, and 80% of that is used in trucks as diesel. So if we are able to enable hydrogen, especially in terms of hydrogen ICE, then we have a clear winner there.
So you have a strong alternative in hydrogen to address the fuel import bill challenge that we have.
Yes.
But again, at the end of the day, you need first source of hydrogen. Second, we need the cost. Third, we need the consumer. What are the three things that will, in your assessment, ensure that there are viable technologies that a consumer is willing to pay the price? So because it's a very price sensitive segment.
So if you look at now, when it comes to policies, we clearly need to have a stable long-term policies and support. It cannot be intermittent. And government has done its part with the green hydrogen mission. And we also see energy players coming in and committing investments. So this must be sustained and further increased to see this happen. Somewhere down the line, if we have to meet net zero requirements, we have to move in this direction.
Right.
Second, when it comes to cost on the powertrain itself, if you go in the direction of hydrogen ICE, it's more or less like a diesel. The cost adder comes in terms of the trunk system.
Right.
So
it's only the carbon fiber tank which calls for an extra incremental.
Exactly. So today it is all held by few manufacturers globally. So how can we break that and localize
it? Invite investment into carbon fiber tanks, because that's a critical element. Without that, a hydrogen tank.
Yes.
Yes. The transportation of hydrogen is also one of the critical factors, isn't it?
Sorry?
Transportation of hydrogen?
Transportation, yes, hydrogen being the lightest. And today we are looking only at gaseous hydrogen. So you need to compress it, cool it, compress it, and therefore there's cost added in terms of compressor. Even refueling infrastructure needs a compressor and cooling. So these are the places where all contribute to finally the cost of hydrogen.
Right.
But one advantage is if I look at kilometer per liter of diesel and compare it with kilometer per kg of hydrogen, we will see it 3 times. So hydrogen will give 3 times the kilometer. So without cost adders, if I look, I can accept a price of 3 times diesel.
Right.
But let's say I take 2 times or 2.5 times, very soon in a long-haul truck, I should be able to break even. Maybe within a year or in a year's time, we should be able to break even.
Why don't you reflect a little bit for our audience on E20 and some of the challenges that an industry or a user today who already is running on the vehicles bought in the past, what are the challenges that we could face?
I think when it comes to E20, I think we are in a very good position, and government recognized the benefits. I read somewhere that more or less in the last 1 decade, over 1 lakh crore rupees or $13 billion savings with 19.6 million metric tons reduction in crude for transport, and around more than 500 lakh metric tons CO2 averted.
Savings.
Yeah.
Right.
So when it comes to technology itself, I think for E20 we are quite comfortable.
You don't foresee any challenges?
No, at E20 level, no. On the technical, both engine and fuel system side, there's no issue. We are not seeing it.
As you move towards E85, E100?
Yes. So also production side, E20 is not a concern. Now when we go to E85, in 2024, we had about 50 billion liters of gasoline used in our market.
Right.
You have to go to E85, so you have to triple or 4 times the production of ethanol.
Right.
And depending on sugarcane is not going to be sustainable. We need to depend on 2G. But the processes, which is basically enzymatic hydrolysis of sugars from bio waste, etc., that's a challenge. It is not commercially mature to the level of a 1G.
Right.
So E85 is going to be a challenge in terms of production. Again, E85, we have to be careful about the fuel quality. Today, whatever IS standards which we are releasing, there are some certain issues like we still need to clearly define inorganic chloride content and water content, because these can cause electrochemical corrosion and other corrosion from water. So when we go towards E85, on the system, these are the challenges that we need to do. And the entire value chain must be looked into with respect to corrosion.
Maruti Suzuki is pushing towards CBG as a strong alternative. How do you see that? How different is it? I mean, again, it's got to do with source, infrastructure. CBG as an alternative from a Bosch standpoint. How do you see that?
We are not too much working on this. For us, from fuel system side, it's like any other gas.
Right,
so the source again is the problem.
Right.
So again, probably Mr. Anup San will know the percentage of use.
Right,
But
right.
for us, the fuel system will remain the same. So it's not a concern.
Let me begin, Mr. Chaudhary, with the E20 and three-wheelers. I mean, does it change anything?
See, basically, technology is already matured. The water structural changes are required in engine or powertrain component. It has been already done in terms of adaptation of this E20 as a fuel. So once fuel means E20, we don't see any challenge. And again, particularly in three-wheeler, if you really see, the vehicle don't run on the gasoline. Gasoline fuel is always treated as a limp mode.
Right.
In case of emergency only, either it runs on diesel
Right.
or diesel vehicles, or when it is a CNG, mainly it runs on CNG only. So in case of emergency only, the gasoline is used
Right.
as an operating point. But when it comes to adaptation of E20, technically we don't see any challenge, and,
Right.
and our products are ready for that.
Right. Mr. Deshpande, if I could bring you in terms of the challenges that you see with regards to alternate fuels and getting the cost right with the scale still at a very low volume, what is the way out of it? At the end of the day, one has to move towards the net zero targets, yet the volume is a challenge. You have solution. So what's the way out of this in your assessment?
So I think it has to be a little bit multi-pronged approach. So number one, I think what we require, to the earlier point that the other panelists were also making, is we are now talking about CAFE kind of norms coming for commercial vehicle segment. I think the stringency of those norms and being able to consistently kind of put forward CO2 reduction year on year, that is something that's going to drive the industry towards adoption of new technology. And I think that will be the starting point, because that will start actually the first cells, which will start, bringing in the volume that we need to actually leverage the cost. So that for me is the very first step. So CAFE and what the SIAM group is doing today, along with the representative regulatory bodies, BE, is a very key step in that regards, specifically when I'm talking about commercial vehicle. So I think the more they can actually push forward towards going to the net zero kind of solutions, maybe we have a target of 2070 as a country, but
Right.
how commercial vehicle can actually spearhead some of this, that's going to be one key step. So for me, that's number one. That's important to bring in volumes, first of all, because unless the industry sees the volume, I think...
And that is
there
through
will be
regulation is what you're insisting.
That's the regulation that we need. Number
But
two,
that also that leads to increase in cost?
it will, but I think what we have seen, and this is again, just being in this global company, my reflection, today if you look at actually a market like North America, there are places where we have to kind of work with OEM to sell, say, one specific application of a gasoline product to substitute the deficiency of CO2 of maybe 5 vehicles on diesel. So that's the kind of trade-offs we are talking right now, and that's where this fleet kind of economics actually becomes more viable, even for an end OEM and also for our end customers. So that's how it typically goes, that you have to probably start somewhere, but over the time, I think it starts actually getting towards, as the volumes come in, the cost structure starts becoming much and much better. So that's just the reflection from the regulation perspective on the cost front. The second thing, of course, we can definitely kind of look forward to, and again, this green hydrogen mission actually is a great example in that regards, is in order to bring the technology cost down, one important aspect is how we can make it indigenized, so something which is more localized, more relevant content. Of course, when we look at global solutions, they are usually what we call as bells and whistles, lot of stuff that we typically would not need in a market like India. So how do we bring those, take those off and actually then bring a solution that's more palatable for India. But this all requires actually a bit of joint working between regulatory bodies and the OEMs to actually try and develop these kind of solutions. So again, the green hydrogen mission is a good example in that regards where we are trying to do this. I think there are more opportunities in the space of LNG and other alternate fuels like biodiesel. And last but not the least, again, more from a regulatory perspective, is having very clearly defined standards for even things like biodiesel, right? Because today, talk about biodiesel in the market, actually there is more or less, I would say in a commercial segment, there is a fear at what sort of fuel is being used because of lack of adequate, I would say, quality controls and standards being defined as to what's getting sold under name of biodiesel. So these are the areas where actually we can actually focus to bring a scale into this game.
Right, Mr. Donakonda, I mean, if you could reflect a little bit from the global experiences, do e-fuels, synthetic fuels make sense in the Indian context, or we are too far ahead in the future, it's not relevant from an Indian standpoint? How do you see that?
One of the, there are two elements which need to come together for e-fuels to happen. One is what we call as carbon sequestration, the ability to capture carbon. And the second thing is your ability to produce hydrogen through electrolyzers.
Right.
So the later is definitely possible in India because you have no dearth for light in India. So photovoltaic has a lot of potential. So that's a given that it's a great opportunity in India. The next thing is we also need to find out means and methods how we are able to capture this carbon, because ultimately you need to have that, then go through some kind of an equivalent of a fractional distillation process to be able to produce gasoline or petrol or diesel. And the good thing about the diesel that you get out of this is that some of the elements which are responsible for soot formation and others which come through fossil fuels will not come in this case.
Right.
So I would say that e-fuels have a great potential. The biggest challenge for e-fuels is about meeting the price points which are comparable to diesel today.
Right.
From an engine technology point of view, at least I'm sure even my colleague from Bosch, former colleague from Bosch will agree that most of the current diesel systems that we have, the common rail systems, are almost directly compatible. At the most, you may have some little bit of calibration and a little fine-tuning, or what we call parameterization in software, which may be needed for considering the real-world conditions. I think that's very promising. The main challenge still remains price.
Right.
Are you able to bring it down to the price of what you directly buy diesel or buy crude oil and produce diesel versus what you make through what we call it syngas, the combination of hydrogen and CO2 coming together and then doing it. So it's all about price that matters. But I would want to really bet on it, because I said we have the entire value chain which is so established. Your fuel supply, nothing needs to be changed. You could just have them in the regular fueling stations, the OEMs in India, the Tier 1s in India, all of them could continue to do business as usual.
So what will it take to see a potential of e-fuel in the Indian market, in your assessment?
I think somebody willing to make that initial investment. There are a lot of synergies here. Let's look at it in this way. The philosophy we follow, at least in my company, is we say that going forward, the path to zero emissions, we will see a lot of synergies in electric vehicles, BEVs, and hydrogen coexisting. The reason is, when you're trying to set up the infrastructure fast, it's about power generation. So power generation, you can scale very fast at not very high cost. The biggest challenge is grid upgrade. And if you want to address the grid issue, the costs are phenomenal. Now, if you have energy to the molecule, as we call it for hydrogen, and you can have it transported and used where you want to use it, it basically means you can continue to produce it, you can produce hydrogen at the place where you need. And hydrogen is an important component of e-fuels.
Right.
So there's a third dimension to the synergies you get in what you produce.
Right.
So I would say India should take it seriously, or as anyone in the world should also take it equally seriously.
Ms. Anthony, your views on e-fuel and possible synergies. Have you started seeing interest from local players to look at alternatives? Yes, we need the source of fuel first.
That's the biggest topic. But things are happening in Germany, Bosch Germany. But in India, we don't see that much of traction at the moment.
So what's the right path in your assessment? What are the low-hanging fruits from an alternate fuel perspective that Bosch sees that will help India in its net zero ambition? And what are the technologies that Bosch is betting on?
Now, for example, very clear, the ethanol, and if we are able to scale up production and find alternative sources, I think government is doing a lot. We are collaborating with Brazil. We can learn a lot from Brazil, also United States that way. If we are able to scale that up, that's very good, very pragmatic. Because if you see even biodiesels, we have been talking a lot, but even if we are able to do 5%, it'll be great, but then against the source. So being pragmatic, biofuels in terms of ethanol, and in the long run for hydrogen for trucks.
Right. Mr. Chaudhary, in your assessment, what are the 2 or 3 key pathways that you see towards a cleaner alternative?
See, particularly in the segment in which we are operating, basically our entire product portfolio, we have best fuel agnostic. So whatever fuel comes in future, our products should be ready for that. So basically diesel, CNG and EV powertrain, all these are the key, basically fuel agnostic products are already developed and ready. So whatever upcoming fuels are there, whether it is ethanol or biodiesel or any type of blend is or flex fuel is there, it's a upgradation to existing product portfolio. So we are ready for that, and in the segment in which we are operating, I think the priority wise CNG, then EV, and over a period of maybe 5-6 years, diesel may die down on its own.
In your segment?
In our segment. And then ethanol, flex fuel will come. Basically that will come.
Right.
Hydrogen will take time, particularly in our segment. In commercial vehicle, yes. Maybe it will come based on its operating cost and the efficiency.
Right. If I could bring you in, Mr. Deshpande, how much more cleaner can the ICE get, and what are the technologies that you're betting on that is going to help India in its path towards net zero?
So, talking specifically about ICE, and maybe I'll focus on diesel. I think in the earlier panel, we spoke about BS7. And I think panelists very rightly pointed out that if you look at today's diesel engines, I think in some cities of India, they will be producing cleaner exhaust than what is in ambient air, right? That's a reality, right? That's the extent to which cleanup has happened in the tailpipe emission. But where we can definitely still continue to develop the ICE solutions in all spaces, including diesel, gas, hydrogen, is on the efficiency side, on the CO2 side. So just to give you some examples, right? When we were back in the BS3 days, we used to have engines which were capable of probably being only 100 bar or 110 bar PCP capable. Now, come BS4, most OEMs took that up to about 150 bar. What this essentially means is that you can have much cleaner combustion in cylinder, which means that you can actually improve the efficiency of the overall engine and ensure that you give really good power and torque to the end customer such that you typically are able to downspeed the entire powertrain. So I see that trend continuing. So come now BS6, we are probably about 200 bar. Most of the OEMs are capable of having that kind of an engine, specifically in the commercial vehicle segments. And BS7, this will further go up. So I think that's the trend that I see, that very clearly we can improve not on the tailpipe emissions because they are very much clean today, but continue to improve on the efficiency of the powertrain as a whole. And for me, that's the key enabler to ensure that the ICE solutions survive what we spoke in the morning session, right. The upcoming, I would say, headwinds which are ahead of the ICE solutions.
Right. Mr. Donakonda, looking at the global context, what's the mix you foresee when it comes to, I'll stick to commercial vehicle, given the Indian context. What is the mix you see on gas, on diesel, on hydrogen, on biodiesel?
Okay. On CNG, you'll still see a big presence in India in the mid and the long term. And I don't know if you have also read it in the news that China, which was known to be a predominantly diesel market for commercial vehicles, has, because they started getting relatively low, cheap, inexpensive natural gas from Russia, their fleets have almost largely moved. In fact, it's a massive change towards CNG. So I think it's important for OEMs to focus on multiple technologies, keep multiple options, because we never knew this transition from diesel to CNG in China will happen so fast. Right. And it was something like within a few months, and the agility of companies to very quickly adapt their portfolios to give a CNG in their offering is something which is a learning for the entire industry. So I think going forward, yes, in a country like ours, blended fuels matter. Even in Europe, we use something called R33 diesel, which is almost 33% of non-classic fossil fuel, and with the rest of it, 67% fossil fuel, and then you have this hydrogenated stuff, and then you have biodiesel, 7%, 23%, and this is catching up. So I'm sure the idea of having something blended will be a transitionary technology in the midterm, because I don't think a country like ours is, at this point of time, if we said the truck market is extremely TCO, I would say the Indian market is far more TCO focused.
Absolutely.
Right, so we will always look at what little more can you get out of the technology in terms of what makes value for fleets, what makes value for the company and our economy. So I think that will
Given
be
the fact that you operate, you cater to the global operation, do you think in the gas space, as Mr. Deshpande also earlier mentioned, that potentially India could leapfrog and cater to the global needs? And is Daimler Global looking at India from catering to the global requirement of various alternatives?
Yeah, so we have a major presence. We have it right here in Chennai. It's called Daimler India Commercial Vehicle.
Yes.
Of course, I don't...
From an alternate fuel perspective is what I meant to
So and that's very clearly focused on trying to be very market specific, focusing on hyperlocal requirements of what the market has to offer, and also giving the best-in-class technology that we have from anywhere else in the world, which can serve the Indian market. So in that sense, we are very deeply rooted in India as much as we are focused globally.
And Mr. Anthony, from your perspective, how do you see the future mix across various segments, and how is Bosch steering itself to a multi-pathway?
We have some scenarios called Evo Plus, so that's
Can you explain to them?
Let's internal, and I agree with the panelists in the morning that we cannot put a number because it's changing. For example, if you talk about CNG and suddenly CNG prices drop and there is an inventory buildup at the OEMs, so I think it's very, very critical. But in the long run, like for example, passenger car, everybody was talking about 30% electric. So these are some directional figures that we can think of, but we have to prepare for all scenarios.
Right. And just one final comment from each one of you. If 2 or 3 key things that you think the country needs, be it from infrastructure, skill, incentives, what will drive India towards an accelerated path towards net zero, Mr. Chaudhari?
See, in terms of fuel availability, infrastructure, making infrastructure available for any type of fuel is government will have to take care. Coming to industry, for different types of fuels or different technologies, the skill sets required are different in terms of manpower, engineering competencies, and nowadays nobody wants to work on ICE actually.
Oh, is it?
In engineering field, no, everybody wants to work on EV, mechatronics. So the skill set availability because of technology, in technology everywhere now it's a mechatronics, in after treatment it's a chemical engineering. So multiple skill sets availability is very, very complicated, means difficult, and that capability development, whether it's at the educational field or during, let's say, recruitment process or during working, the learning, one capability. These are some challenges industry and government will have to work.
Right. If I could bring you in, Mr. Deshpande, Cummins has given a lot of Indians to the global operation over the years. What do you think from the skill set perspective, and what would be your ask from the government side?
So I think we spoke about government in terms of having a very consistent approach towards policy, and actually
long-term clear policy.
Long-term very clear policy, stable, and also ensuring, I think that's also been the focus of the government to say that we got to be at par with global. Like we can't be laggards in terms of emission, because again, what we did not discuss today, but you partially touch based, is how then the Indian ecosystem can actually start exporting both products and technologies out of India. That's a very key thing, and I actually see that happening, like I mentioned in hydrogen case also.
From a hydrogen perspective.
And even on the conventional space, where to the point that was made earlier, probably are the lowest cost country in terms of cost of producing things. So that's a very important aspect.
Yeah, Volvo, Daimler, for them, India is like the hub for medium duty engines. And
absolutely. And Cummins, we ourselves actually have a dedicated plant in Fulton, which actually focuses on exports just out of that plant to all the global regions.
So that gives you scale,
That gives us
improves
scale.
cost.
Absolutely. And imagine the kind of impact it can create in terms of the ecosystem, because suddenly your suppliers are not working on X, but probably X into one and a half
makes
times the
sense.
scale. So
On the
it's
skill, what's your view, skill set?
So skill sets wise, I think very rightly pointed by Sandip. Actually, today we are talking about multi-skilling engineers, not just working on, say, one ICE technology or one given field of, say, just the mechanical design. We're talking about multi-skilling, of course, with the advent of AI and ML coming into the force. There's a lot of efficiencies that we can drive by using these technologies such that people don't need what we call within Cummins is at least like a T profile, which we say that a person needs to go to a depth, spending maybe 3-4 years in a given area, but then for him or her to grow in the career, go across multiple. That's what I call multi-skilling. So somebody who's like a really good performance engineer then comes up and
so
looks
constant
at overall
upskilling in the R&D front.
Upskilling in the R&D and looking at more of the system approach, right? Because that's what I think will differentiate, and that to an extent negates the anxiety that people have that if I'm working on a program which is diesel based, what's next for me, right? Whether I'll get the next program or not.
Yeah.
I think that's what we tend to think about. I do feel the other critical skill set for people to know is around software, because most of our products today are electronic, run by software. I think in due course of time, everything will become software-defined vehicle.
Right.
And that I think will become an important skill.
Right. Mr. Donakonda, I mean, you cater to the global needs. Skill has been one challenge, and do you think that once we have the skill set here, then we could probably have an accelerated path, or is that's one of the core requirements?
To start from a global view, the thing is we are going through very uncertain times. So we really can't say which technology is going to prevail in a few years' time. So, like I said, in my company, we focus on diesels, we focus on battery electric vehicles, we focus on fuel cells, we also focus on hydrogen combustion. And because of the trends globally, we do have certain markets where we are very strong even with CNG, but then we'll have to see how to transfer those technologies to markets which need them at a suitable point of time. So what we had also seen a few years ago was in Germany or in many countries in the European Union, the subjects on internal combustion engines were slowly getting out of the syllabus, and there are no takers for these courses. But then with hydrogen combustion, and I think we were trying to do a recent search on trying to see how do you get people, then we realized in many regions this is the case. And as far as I know, if hydrogen combustion engine is able to give you a diesel-like performance, it's going to be one of the mainstays of technology for a long time to come. So I wouldn't say we need to stop something. I would say let's focus our energies. The core engineering competencies are anyway required, and then it's all about how do you adapt it.
The challenge is the resources are so many, and you still have to make money and yet offer it
to be frank,
at the right cost.
To be frank, I'm a mechanical engineer with a master's in IC engines. I started my career in Ashok Leyland in engine research and development, and then after about a decade, I moved to Bosch, and I was mostly in control systems, electronics, software. Then I did for some time some hybrid work, something on pure electric systems. And then I didn't know whether I was an electrical engineer, a mechanical engineer, or what engineer. And then I was also handling exhaust treatment for a long time, where you're also dealing with chemical engineering. Right. So I would say it's important for us to be well-rounded engineers.
Multifaceted.
And fundamentals have to be very strong.
The industry would need many more people like you in order to ensure that the right solution at right cost.
And then you need to have the fungibility to be able to switch from one technology to another with minimum time.
Right.
From the government point of view, I would say the government, I've been tracking certain things on the policy for a while, and I think the government has done enough in terms of enabling kickstarting a new technology. A few years ago when FAME 2 was launched, I thought the intent was right, because they just wanted the people to get into the mindset, make their initial investments, because that was also a time when most companies had already made massive investments in BS6, Bharat Stage 6, and then they said we have only so much of R&D funding. So there were demand-side incentives, there were supply-side incentives. I think they have been very sensitive to the industry in terms of trying to...
Still at low scale though, but it's a long journey. Just final words, Mr. Anthony, from your end. In your assessment, it is a multi-pathway. How do you still make money and have right skill sets?
Maybe the making money part, I think we know. So I would comment a little bit on the skills. So we have been talking about skills at the engineering or R&D. But what we need to really is skill up the entire organization. So we have to look at the width of skilling and depth of skilling. Now, for example, about 5 years back, we ran a program within Bosch called Phoenix, and all functions, HR, purchase, heads, not the heads, I mean, people got together over a period of 2-3 weeks regularly to find out, looking at how the market is changing, what should be the skilling difference, what skilling is required. Now, for example, one example was digitalization was very strong at that point. In fact, we had a company-wide program with WBTs and others, external.
What about supply from the market? Because you will need more engineers as the market expand. And the right skill set, do you think there's a need for a rehaul in curriculum, given the complexity of the challenge that is there on hand?
Yes, that is anyway. Now, if you go, some of the institutions now with the autonomous institutions, they are changing quickly. But those still not autonomous probably needs to revamp their syllabus to cater to this changing need. And as I mentioned, you need both width and depth. So you need to have cohorts who go deep into the topic, but we also have to train the entire organization. For example, now we are even teaching HR very small modules, what is hydrogen engine, so that they can help us recruit right people.
Fantastic. Thank you very much. On that note, thank you very much for listening in, guys. We've run out of time and appreciate you spending time with us. Thank you.